Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the confidence interval for the difference of two population means. And in this video, it is about samples being dependent. So what are the keywords that indicate that two samples are dependent? So the keywords here are, for example, match data, uh, or maybe pre-test and post-test. And I'm going to illustrate what it means by match data or pre-test and post-test. Now, suppose that you have this group. Okay, so this is group 1. Hang on. So let's say that we have this group here, group 1, and this is another group which is group 2. So when you talk about match data, you can think about the subject in group 1 being matched to the subject in group 2, for example, and this subject here will be matched to this subject, and let's say this one will be matched to another subject in group 2. Now usually this arises when you have, for example, twins as you have twins as subjects. Okay, so you want the twins to be as biologically identical as possible, so you take twins as subjects, and therefore the result here will be matched accordingly. So you are interested to find the difference between the results for each pair of twins. So that is what we can think of. That's what example of match data. Okay, match data. Now what is pre-test and post-test? So pre-test and post-test, you can, for example, have two different sets of data. So this might be the first set and the second set, and usually you are taking the same subjects. So the first subject here will be tested, so there is a result here, and then after some sort of intervention, the same subject here will be tested again. So we are interested to see the difference between the result here. So again, we have a different subject, so the result of pre-test will be considered here, and after some sort of intervention, this person will also be tested again, and you get the result of the second test, which is the post-test, and you are interested to find the difference of the results. So that's the idea of pre-test and post-test. And in this case, although the samples seem to be two separate samples, but they are dependent in nature. Alright, therefore, the starting point to find the difference in the population means is, so the starting point will be to find the differences in the data sets. Okay, so these differences here will give rise to the new data. So by finding the differences, you will get a new data. We call this new data as D. Now, once you manage to get this new data, you can find what is the mean of this data and what is the standard deviation of this data. In the formula here, the mean of the new data is represented by D bar, and the standard deviation of the new data is represented by this one here as D. So therefore, in order for you to construct the confidence interval here, you need these two information. Okay, and notice that we are using the term mu D instead of mu1 minus mu2. So this is the difference of the population means. Instead of mu1 minus mu2, we are using this different notation slightly because we are already taking into account the differences in the data set. So therefore, we just represent it as mu D, okay, to denote that this is the case of dependent samples. Right, now this one is the T quantile. The degrees of freedom is n minus 1, and this is alpha over 2, which is the probability that you can find at the top of the T distribution table. And if you want, you can also write this formula in a compact form, and it is going to look like this: D bar plus minus T n minus 1 alpha over 2 times with the standard deviation of the new data over square root n. Okay, perhaps the application of this formula is going to be clearly visible to you all if we look at the example here, and we will try to implement the formula which you have seen in the previous slide. Yeah. Alright, in this example, a dietitian is interested to see if the person's cholesterol level will change if the diet is supplemented by a certain mineral. The subjects were pre-tested, so this is the keyword that shows we are talking about dependent samples here. So this is the first group of data, this is the second group of data. And you can see that this is the same subject is being tested twice. So before it gets supplemented by the certain mineral, this is the result, and after the 6-week period, the result is given as this one. Okay, so now we are interested to find the true difference in means, and because this is an example of dependent samples, the true difference in means will be represented as mu d. Okay, so we are interested to find what is the interval estimation for mu d, and the 90% confidence interval here indicates that your alpha is going to be equal to 0.1. Okay, because this is 0.9, therefore alpha is going to be equal to 0.1. And as I said earlier, the starting point of this is by getting the differences in the data set. So we are going to find what is the difference of 210 minus 190. So the answer is going to be 20. This one, the difference is 65, negative 2, 2, negative 1, and 16. And we are going to call this new data set as D. So this is the new data that we have here. And based on this new data, you can find the mean and the standard deviation. All right. So that's what we're going to do next. We're going to find what is D bar. So D bar is the summation of all the values here, which is xi from I equals to 1 until 6. And then you will divide that with n, which is 6 in this case. Okay. And so this is equal to having 20 plus 65 plus negative 2 plus blah 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 plus 16. And you divide that with 6, and you will see that the answer to this one is 16.67. So that is the mean of the new data that we have here. Next, we are going to find the standard deviation. But in order to find the standard deviation, we need to calculate the variance first. So this is the variance of the new data. And I'm going to apply the formula, the easiest formula to calculate the variance, which is given by this one here. From I equals to 1 to 6 minus the summation of xi squared, I from 1 to 6 over n, and this one is over n minus 1. So now what we have to do here is for this part here, it basically says that you need to square all the values and then you add the values. So this will become 20 squared plus 65 squared plus blah 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 16 squared. So that is what's going on for this part here. Next, for this one, this is going to be the summation of xi, which is equal to this one here. So the summation of xi is 100, and then you're going to square it. So you have these two outside the round bracket. So the summation of xi here is 100, and you square it. Next, okay, so minus this one is over n, so which is over 6, and this one is n minus 1, which is over 5. And once you punch in the values into your calculator, you'll be able to get the answer is 644.6667, and therefore the standard deviation for this data is just taking the square root of this number, and this is equal to 25.3903. So now we are going to use the results here in order to find the confidence interval for mu d. Alright, so the formula is d bar plus minus t n minus 1 alpha over 2 sd over square root n. So d bar is 16.67 plus minus n minus 1 is 5, alpha is 0.1 over 2, which is going to be 0.05, sd is 25.3903 over square root of 6. So if you look at the t distribution table here, you will find that the value of t quantile is going to be 2.015. Okay, 2.015, and you multiply that with 25.3903 over square root 6, you will be able to get the answer, the final answer. Okay, I'm just going to write down the final answer. It's going to be mu d between negative 4.22 and 37.56. So this is the final answer. Alright, so now based on this answer, can you state whether the person's cholesterol level is changed after being supplemented by that mineral? What's your answer to that question? Alright, I will leave that to you guys to think about, and for the moment, that's all for now. Thank you very much for watching.